In this video, we're going to learn how to solve problems involving limit at infinity of rational functions very fast in seconds, especially for multiple choice questions. Now, after going through this video, you'll be able to solve problems involving limit at infinity of rational functions in seconds, as I'll be showing you the trick behind it to apply. Okay, so let's begin with the first example I have here. Now, there are three principles involving limit at infinity of rational function, of which I'm going to show you each of the three principles. So the first principle I have here, let me give you this, show you this typical question. If we have a question like this, 3x cubed plus 5 over x squared plus 3. Now when you have a question of this formula, you ask to find maybe the limit x is tending to infinity, and has to find the limits of this function. Now, the first principle states that whenever the limit of a function is tending to infinity and the highest power of the numerator becomes greater than the highest power of the denominator, the limit of the function is said to be indeterminable or does not exist. So, the answer to this question will be infinity. Thus, is indeterminate. We cannot define these limits. Okay, if you look at the numerator values, the highest power of x here is 3, and the denominator, the highest power of x here is 2. So the power of the numerator is higher than that of the denominator. So in this situation, the limit will be indeterminate but does not exist. So this will be our answer. Now let's check another situation. What if the limit x is tending to infinity, and we have a scenario or a situation like this where x squared plus 3 over x raised to the power 3 plus 5. Okay, wait, let me add 3 here. Okay, now in this situation, you will see that the highest power of the denominator is higher than that of the numerator. At the denominator, we have the highest power to be 3, numerator, the highest power to be 2. So in this situation, when the highest power of the denominator becomes greater than that of the numerator, the limit of the function is said to be 0. So it's as simple as that, guys. And lastly, let's look at the last situation, last principle, where we are giving a limit x tending to infinity, and we are giving a question of this formula minus 2 plus x minus 2x squared all over 3 x squared plus 2x plus 5. Now, whenever you are given a question like this and you ask to find the limits of the function at infinity, now you check if the both powers are the same. The limit of that function will be the coefficient of both sides. Now, if you check this question, the coefficient of the numerator value, the highest power of the numerator values here is 2, which is this 2. The highest power of the denominator values is also 2, this 2 here. Now, in this situation, you take the coefficient of the respective terms. So, the coefficient of minus 2s squared is what? Minus 2. Over coefficient of this term 3s squared is what? 3, and this will be the answer. Just take the coefficients and you'll be good to go. For those of you that don't know what coefficient is, coefficient in mathematics simply refers to a number behind a variable or an unknown. For instance, coefficient of x is 1 because 1 is behind this variable x. Coefficient of s squared is still 1. 1 is invisible to this s squared, so it is the number behind this variable s squared. Coefficient of 2x squared is 2. Coefficient of 3s cubed is 3. So coefficient is the number behind the variable or an unknown. So guys, with this we have come to the end of the class. I hope you learned something interesting that will help in the long run.